Hello everyone, it's Mr. Salimata over here, and in today's lesson we'll be looking at completing the square. Now in our previous lesson we did learn how to recognize and factorize perfect square trinomials. We also generated a general rule that works for perfect square trinomials. Yes, and we're talking about these perfect square trinomial identities. Now let us begin this lesson by looking at this quadratic trinomial over here. Let us try to recognize it if it is a perfect square trinomial, and if it is a perfect square trinomial we can then factorize it into squared binomial. Yes, so let's do that. Okay, so now, is x squared a perfect square? Yes. Is x squared a perfect square? Yes. X squared is a perfect square, right? Is our last term over here a perfect square? Yes. 16 is a perfect square. What's the square of 16? 4. Is our middle term over here twice the product of the square root of the first term and the square root of the last term? Let's check. So we're talking about twice. That's 2. What's the square root of x squared? X. What's the square root of 16? That's 4, right? And if we take the product, we'll have 8x. Yes? So there we go. We can now see that this quadratic trinomial over here is a perfect square trinomial. So then we can factorize it into what? Squared binomial. And if you look at this form of our quadratic trinomial over here, it's in this perfect square trinomial identity, right? So then we can just factorize it in this form over here, in this squared binomial, right? So let's open our brackets. Yes. What's the square root of x squared? The square root of x squared is x. Yes. Okay, so then how do we then find the constant in the bracket? To find the constant in the bracket, we just have to take the half of the x coefficient. So we are talking about taking the half of the x coefficient, and the x coefficient is 8. So 2 into 8 is what? Is 4, right? So this 4, this constant 4 over here, the 4, is what we have to put in our bracket, which is positive 4, and then we square it. Okay, so we have now what? Factorized this perfect square trinomial over here. Yes, and if you look at this squared binomial, it is this squared binomial right here. Yes, it's in this form. Okay, so now I have a question for you guys. Do you think it's possible to transform an ordinary quadratic expression into a perfect square trinomial? Well, let's see. Yes, so let's say we have x squared plus 8x plus 3. Yes, let's say we have this quadratic expression over here. Do you think we can transform this quadratic expression into a perfect square trinomial? Okay, let's get into it and see. Yes, but before we move along, please note that this quadratic expression over here is what is in the standard form of ax squared plus bx plus c. Yes, this is the standard form of a quadratic expression. Yes, okay, so let's get into it. Let us look at our first perfect square trinomial here that we just recognized, right? And then let us look at this ordinary quadratic expression over here. What number do you think we can add to this expression to transform it into a perfect square trinomial. We're looking at this expression, and then we also look at this expression. We can say that we can add a 16, right? We can add a 16 to this expression. Yes? Okay, so now let's try to add that 16. Yes? So let's say x squared plus 8x plus 16 plus 3. Okay, so then have we now transformed this ordinary quadratic expression into a perfect square trinomial now that we've added a 16? So here is the thing. Whenever you are transforming an ordinary quadratic expression into a perfect square trinomial, you have to make sure that you don't change the value of the expression. Now, what do I mean by that? Okay, let us set x to 0. Yes, let us set x to 0 in our initial quadratic expression. So let's do that. So we shall have, we're setting x to 0, right? So our x squared will be 0 plus our x over here will also be 0, right? And then plus 3. Yeah? Now, 0 plus 8 multiplied by 0, 8 multiplied by 0, that's just a 0, right? So then we shall have 0 plus 0, that's 0, then plus 3 equal to 3. So this is the value of what? Of this quadratic expression over here, right? Okay, so let us do the same to this expression that we just added a 16. Yes? Let us set x to 0. Okay, let's do that. So x squared, that's 0. Yes? Plus 8. Yes? Or 0 plus 16 plus 3. Let us simplify. Yeah? 0 plus 8 multiplied by 0, that's 0, right? That's just a 0, okay? That's just a 0 here, this one. And 0 plus 0 is also just a 0, yes? So we shall remain with 16 plus 3, that's 19. Right? Now, if you look at the initial quadratic expression over here, its value, yes? Its value is what? Is 3. But then the one that we just added a 16, the value is 19. And remember, I told you when we want to transform, yes, an ordinary quadratic expression into a perfect square trinomial, we have to make sure that we don't change the value of the expression. But here, the value of the expression has changed to 19, right? So then, what can we do? Okay, so how about, yes, how about we add this 16 and also subtract this 16? What do I mean by that? X squared plus 8x, we add the 16 and then we subtract the 16. Okay? Then plus 3. Now, let's look at these two terms here. Positive 16 minus 16 is what? Is 0, right? Those cancel out. And if you look at this expression over here, it's the same, it goes back to the same to our initial quadratic expression, right? So that means the value of this expression, when we set x to 0, it will be what? It will be 3. So the value of the expression has not changed. So then what does that tell us? That tells us that we cannot only add a number, but we also have to subtract the same number. I'll say that again. Whenever you're trying to transform an ordinary quadratic expression into a perfect square trinomial, we just don't add a number, but we also subtract the same number. In our case, we don't just add the 16, but we also subtract the 16. Yes? So now, let's do that. X squared plus 8x plus, yes, the 16, and minus 16 plus 3. Okay, now, if we look at this expression over here, that's a perfect square trinomial, right? So that means we can what? We can simplify that, or rather we can factorize it into what? Squared binomial, right? Okay, so let's do that. We open our brackets. What's the square root of x squared? X. What's half x coefficient? Yes. What's half of 8? That's what? Positive 4. We square it. Then let's deal with these two terms. The remaining terms, yes? Negative 16 plus 3. What does that give us? That gives us negative 13. So there we go. We have completed the square of this quadratic expression over here. Okay, so I'm sure we're asking ourselves, how do we get the number that we can add and subtract? Yes, how did we get this 16? Right? Well, in our case, we looked at this perfect square trinomial over here, and then we said, or rather we observed that, okay, they look similar. Yes, these two equations look similar. If we add a 16 to this equation over here, then we'll be able to transform it into a perfect square trinomial, right? But then later, we learned that we just don't add the 16, we also subtract it. But then the question is, what if we have a different quadratic expression? How then do we find that number that we can add and subtract? Well, to find the number that you can add and subtract, you have to take half the coefficient of x and then square it. Yes? We take half the coefficient of x and then square it. Let us talk about that by using our standard form, this standard form over here. Yes? A x squared plus b x plus c. Yes? Now, we have to take what? The half coefficient of x. And the coefficient of x is b. So let's take the half. And then square it. Right? Okay, so now let's go to our quadratic expression over here. What's the coefficient of x? 8. And what did we say? We take the half and then square it. 2 into 8 is 4. 4 by 4 is 16. So you see, this is how we got the 16. Or rather, this is how you can find a number that you can add and subtract. Yes? Okay. So now, getting back to the question that I asked at the beginning of this lesson, can we transform an ordinary quadratic expression into a perfect square trinomial? Well, yes, we can, right? We can do that. And how do we do that? We do that by using completing the square. We create a perfect square trinomial, yes, and then we write the expression into completed square form. Now, talking about completed square form, yes, this right here is the completed square form when the leading coefficient is 1. And if we look at this completed square form here, it's the same with our solution over here, right? It's the same. Now, when you have a leading coefficient of more than 1, then this right here will be the completed square form. Okay? So now, let us take a look at some questions so we can solidify our understanding.